Hey everybody, Mr. Gajewski here, and today we're going to do a review of all the different types of problems for solving a system of linear equations by substitution. Let's look at the first one here. System y equals 2x, y equals x plus 5. I want to solve this by using substitution. The reason being is I already have a variable by itself. In fact, I have two. One in each equation. Now when I substitute, all I'm doing is taking an expression that is equal to a variable and substituting it into the other equation. In this example, I already have y equal to 2x. So what that means is wherever I see a y in the other equation, I can plug in a 2x. So let's go ahead and do that. That's going to give me 2x equals x plus 5. All I did was take the 2x, plug it in for y. Now I have an equation with variables on both sides. Now remember, when I solve an equation with variables on both sides, my goal is to get the variables to one side, then solve. In this case, we have a 2x on the left and an x on the right. I want to subtract the smaller one to keep my variables positive. So I'm going to subtract x from both sides. And when I do that, I'm going to get x equals 5. Now I know what x is. I can go ahead and I can take that 5 and I can plug it in for x in the first equation or the second equation. Either one will work. I will get the same answer. Let's plug it in for the first. So y equals 2x. Except this time, instead of writing 2 times x, I'm going to write 2 times 5. Well, what is 2 times 5? I get 10. Now remember, each of these equations represents a straight line. The x and the y values are the values of an ordered pair of the point where the two lines meet. Now when I write my ordered pairs, remember x before y. So in this case, I'm going to write the ordered pair 5, 10. And if I wasn't sure of my answer, I could plug both of the values from this ordered pair into both of the equations to see if they're true. Since this is our first example, let's go ahead and let's do that. So y equals 2x. What is y? 10. And it is equal to 2 times x, which is 5. Well, 2 times 5, we get 10. Does 10 equal 10? Yes, it does. But I'm not done yet. Remember, it has to work for both equations. So my second equation, y equals x plus 5. Y is equal to 10. We think that x is equal to 5. Let's go ahead and simplify. Does 10 equal 10? Yes, it does. Go ahead and circle your answer so your teacher can see. So that's the first type of problem you'll see. The other one you'll see is an equation where they already have one variable solved in one of the equations. The other one does not. So in this example, 2x plus y equals 5. We don't have a variable by itself. Y equals x minus 4. There we do. So we can take the expression x minus 4, and we can substitute it into the first equation for y. So what will that look like? That's going to look like 2x plus x minus 4 equals 5. Now, the plus is outside of the parentheses, so that's like distributing a positive 1. That's not going to change anything in the parentheses. So I'm still going to have plus x, and I'm still going to have minus 4. Now, unlike the first problem we did together, this equation does not have variables on both sides. This has variables on one side. So I don't have to collect the variables to one side. But what I do have to do is combine like terms. So I have a 2x and an x. Those are going to combine to 3x. Everything else stays the same. So I have 3x minus 4 equals 5. I need to undo the subtraction. So let's undo minus 4 by adding 4. That'll give me 3x equal to, well, 5 plus 4 is 9. 3 times x. Let's divide by 3. And we get x equals 3. So now that I know what x is, I can go ahead and I can substitute this 3 back into either of the equations to solve for y. Now when I look at these two equations, which equation is going to be easiest to solve for y? Probably the second one. The second one already has y by itself. So let's rewrite the second equation. Except this time we're going to change this x into a 3 because we found out that x is equal to 3. So we have 3 minus 4. Well, 3 minus 4 is negative 1. Let's write our answer as an ordered pair. X is 3. Y is negative 1. And circle your answer for your teacher to see. Now we can go back through and plug in both of these values to check to see if they work for both. But since we've already done that with the first example, we won't spend any more time in this video doing checks. Let's look at the third example here. Now in this example, we don't have a variable solved all by itself. So before we can substitute anything, we need to isolate one of these variables. Now I prefer to work with variables that have a coefficient of 1. Here we have a 1x plus 4y equals 6. We could solve for x in the first equation. We have x with a coefficient of 1 in the second equation. We could solve for that x. And we have y with the coefficient of 1 in the second equation. We could also go ahead and solve for that y. Now, typically I want to try and find out which one's going to be the easiest, so that way when I substitute it, I'm not going to have as much work to do. Well, if I solve for x in the first equation, I'm going to be substituting something with a 4y into the second one. That doesn't sound too appealing. If I solve for x in the second equation, I'm going to be plugging in a y with the coefficient of 1 back into the first equation. That sounds a little bit more appetizing. Or I could solve for y in the second equation. But when I substitute for that expression, I'm going to have to distribute that 4 times whatever y is equal to. So let's go ahead and let's solve for x in the second equation. So I'm going to rewrite x plus y equals 3. And I want to get y by itself. So this is x by itself. Well, we have x plus y. So let's subtract y to get x equals, well, can I do 3 minus y? No. Those are not like terms, so I'm just going to write 3 minus y. Now I have a variable by itself. I can go ahead and take that 3 minus y, substitute it into the first equation. So x plus 4y equals 6. Instead of x, I can write 3 minus y plus 4y equals 6. I already have the variables collected to one side, so let's go ahead and combine like terms. Well, 3 is the only constant, so I'll rewrite that. But now I have a negative y plus 4y. Well, a negative y plus 4y is going to give me positive 3y equal to 6. Let's isolate the term with the variable, which is 3y. Let's subtract 3. 6 minus 3 is 3. We're going to divide by 3. And that'll give us y equals 1. Well, now that I know what y is equal to, I can go ahead and plug that into one of the other equations to solve for x. Let's use our newly rewritten equation. X equals 3 minus y, and we'll change that y to a 1. So 3 minus 1, x equals 2. Go ahead and write your ordered pair, x before y. So we have 2, 1. And we circle our answer so our teacher can see. And again, we're not going to do a check, but if we wanted to, we could substitute both of these values into both equations, see if we get a true statement. If we do get 2 true statements, we're good to go. We got the right answer. Let's take a look at one last example here. So again, we have 2 equations. We don't have a variable solved by itself, so let's go ahead and let's solve for a variable to get it by itself. Now again, I like working with positives, and I like finding variables that have a coefficient of 1. In this example here, the only problem, or the only variable that has a coefficient of 1 is x in the second equation. So we're going to go ahead and we're going to solve for x in the second equation. So x minus 4y equals 11. I want to get rid of that 4y, so I'm going to add 4y to both sides. 11 plus 4y. I can't combine those because they are not like terms. But now I have a variable x all by itself and the expression 11 plus 4y. Well, I can take that 11 plus 4y, substitute it into x in the first equation. So I'm going to rewrite the first equation, 4y, I haven't changed anything, minus 5 times x. Well, what is x? Well, we said x is 11 plus 4y. And that is equal to 9. So again, I don't have variables on opposite sides, so I don't have to collect them all to one side. But I am going to have to simplify this expression. First step in simplifying this expression on the left is to distribute the negative 5. And please, please, please pay attention to that minus sign. I'm not just distributing a 5. I'm distributing a negative 5. Negative 5 times 11 gives me negative 55. Negative 5 times 4y is negative 20y. And that equals 9. Let's group like terms. So 4y minus 20y minus 55 equals 9. Combine like terms. 4y minus 20y gives me 16y minus 55 equals 9. I'm going to isolate the term with the variable by adding 55 to get negative 16y equals 64. And then I want to undo the multiplication by dividing by a negative 16. Well, positive 64 divided by negative 16. Well, a positive divided by a negative gives me a negative. And in this case, negative 4. Well, once again, I know what y is equal to. So we can substitute that in for y to solve for x. So I'm going to move back over to the left here, where I have x equals 11 plus 4y. But now we know what y is equal to. So we can do x equals 11 plus 4 times, well, what is y? Y is equal to negative 4. Let's go ahead and let's solve for x. Well, order of operations, good old PEMDAS. Can I add first, or do I want to multiply 4 times negative 4 first? I want to multiply first. So this is going to be 11. Well, 4 times negative 4 is negative 16. And 11 minus 16 gives me negative 5. I have an x value, I have a y value. Let's go ahead and write our answer, x before y, -5, -4. Circle your answer. If you want to do a check, go ahead and plug both variables into both equations. Check to see if you get a true statement after simplifying. And if you do, your answer is good to go. That is all I have for you today. I hope that helps. If you have any questions, let me know. Otherwise, I'll see you next time.